Welcome to Brain Vision.
So we can draw this door. We have two bars. And we know that this distance here is considered L. So we can consider the door to be made out of a large number of thin horizontal rods, which this is an attempt at detailing that, and with each of a length of L equaling 1.0 meters. So we can say that there is rotating about one end. This would be the axis of rotation, essentially, because when you open the door, this is the axis about which it would rotate. You can see these two of these rods in this diagram, and it would simply be a large number of thin horizontal rods all parallel to one another. So we can say that the moment of inertia of one of these rods would be equal to 1/3 times m initial L squared, where m sub I is the mass of one single rod. So we can say that for a collection of identical rods, all parallel to one another, the moment of inertia of the door would then be equal to the sum of 1/3 m sub I L squared, which would be equal to 1/3 times the mass of the door, L squared, because the sum of all of the masses of these identical rods would be equal to the mass of the door. So we can say that the moment of inertia of the door would then be equal to 1/3 times 19.0 kilograms multiplied by 1.0 meters quantity squared. And so the moment of inertia for the door would be equal to 6.3 approximately kilogram meters squared. This would be our final answer. That is the end of the solution. Thank you for watching.